Hello everybody, my name is Ethan and I am a CFI in training. It's been a minute since I started my CFI training and I have 3 days until my CFI check ride. So, as is the theme, let's see if I still got it. In today's video we're going to be covering Task Golf of the Private Pilot Airman Certification Standards, which is operation of systems. And I noticed that in my last video in my last videos that I've done, I haven't really covered what the ACS is saying or what it's talking about. So I'm just gonna cover that real quick. So the ACS, every single task is split up into 3 common themes. You have knowledge, risk management, and skills. Knowledge, it's just that. What things do you know? Risk management, it's more scenario based. They're going to ask you questions with very specific examples and just gauge how well you are safety minded. See, just kind of see the gears turn, see what you're thinking through. And then skills is exactly what skills that they want you to exhibit in order for you to pass this check ride. But one helpful thing is the note right here. So at the beginning, this says if K1 is selected, the evaluator must assess the applicant's knowledge of at least 3 sub-elements. So we can see all these different things. We see K2 and K1 right there. So K1, again, is the one that we have 3 sub-elements for. So it's airplane systems including, and then all these different bullet points are K1A through K1L. You'll get asked a minimum of any 3 of these things, but you do have the possibility of being asked a lot more than just 3. So it's important to just have a wide variety of knowledge on all of these things. But the good news is that most of these things are just rote memorization. So there's a little bit of a complication with this lesson, and it's just the fact that my plane is not going to be the exact same as whatever plane you're flying. You know, I fly a Diamond DA-20, which is a T-tail plane. It doesn't have retractable landing gear. It's got a 125 horsepower engine. It's not too awful complicated, but you may be flying a Cirrus SR-20 or a Beechcraft Bonanza or, you know, whatever it may be. So what I'm going to do is not tell you the specificities of my plane. I'm just going to tell you where to find the specific things for your plane so that you can then create flashcards, get an idea of what all it is that you need to know. So starting off with that, we are going to start with the primary flight controls. So primary flight controls are the 3 major controls that deal with our pitch movement. So here's my plane, our pitch movement of up and down, our roll movement like this, and our yaw movement like this. Those are, in this sense, our pitch is our elevator, which is on our tail, on what's called the horizontal stabilizer. So whatever part of the tail is horizontal is typically where the elevator is at. Then we have roll, which is our ailerons. Our ailerons are on the edge of each wing, the tip of each wing, and go inward towards the wing root and then stop somewhere in the middle. And then the rudder is on what we call the vertical stabilizer, or that vertical part right there on the back of it. So what these primary flight controls do is when you move them, they go out and they disturb the airflow that's typically just running smoothly around that area. So if I think about my rudder, if I am flying like this, and this is my little plane right here, and here's my rudder. My hand is just an extension of my rudder. If I'm flying and all this air is flowing through the plane, and then I just stick a big thing out like this, that air is going to hit off of my hand here, which causes my tail to swing in that direction, which then causes my nose to swing in the opposite direction. So that's what our primary flight controls are doing. They're just disrupting that airflow. So then you can get a proper mental image of the fact that if you just think of how the airflow affects it, you can understand how it affects where you are sitting in the cockpit. Typically, rudders are connected with a steel cable. So when I step on a rudder pedal, that cable just gets pulled and pulls the rudder in a certain direction. And then, at least in my plane, the ailerons and elevators have what's called a push rod, which is just a rod that, as you move the stick in one direction, or forward or backward, the push rod extends into a certain spot, pushes it, and then pushes the aileron or the elevator, whichever it is, into the orientation that it needs to be to correspond to the action that you made. That is our primary flight controls. The next is secondary flight controls, and these are where it can get a little bit different, but most planes have what's called elevator trim, and all planes that I know of have flaps. So the flaps are more inward toward the wing root, and the trim is essentially, I like to connect it or give an example of cruise when you're driving. So what cruise when you're driving does is it just holds a specific speed for you, and what trim does for you is it holds a specific pitch for you. But when we learn about flying in cruise or flying in general, we know that we want to pitch for airspeed. So with that trim, essentially what we're doing is it can be actuated either electrically or not electrically. It's just we have what's called a trim wheel, and what it does is, and I have this little video just because it's a really good video, so we can just watch this real quick.
In the cockpit. Now in this example, the pilot is going to move the trim in the up position when viewed from inside the cockpit. The trim tab in this case on the elevator is going to move upward as well. As the trim tab is now exposed to the airflow on the upper surface, then the force of the airflow is going to cause the elevator to move down. What changes in pitch does the downward movement of the elevator create? That's right, a nose down pitch. Now, in this example, the pilot has actually trimmed it in a way that we call nose down.
Cool. So, essentially what that's doing, again, is disturbing that airflow, but it holds our elevator in a specific spot, which that helps us to maintain that speed. So that's what trim does. And I like to think of these secondary flight controls as just a way to make our lives easier. So we talked about trim, and then flaps are the more important one, which they change the surface area of the wing, the camber of the wing, and with that, they allow us to generate more lift, but also more drag, which allows us to fly at a steeper descent. You know, we have more drag, so we're able to descend steeper or quicker, but fly at a similar airspeed, or sometimes even slower. And those are most of the time electrically actuated. The flaps are. I have never seen a plane that they weren't electrically actuated, but again, your plane may be a little bit different. The power plant and propeller. So with a power plant and propeller, I'm just going to tell you what you need to know. Most of the time, all of these systems and airplane description and everything like that are in Chapter 7 of the Aircraft Flight Manual, AFM, or Pilot's Operating Handbook, POH, of your aircraft. Depends on which one you have. Most planes post late 70s have an AFM, but if it's an older plane, it'll have a POH. But in this Chapter 7, it will just list out your power plant. It'll list what brand it is. It'll list how many cubic inches of displacement it has, which is just the volume of the cylinders. It'll list whether or not it's air cooled or liquid cooled and all of those things. And you want to know those things. So for me, I know that my plane is it's a Continental IO 240 Bravo. And it's a 4-cylinder, 4-stroke. It is fuel injected, air cooled, and it's 125 horsepower. That's what I need to know. I need to have that rope memorized. I need to be able to understand what my max continuous my max RPM is, my max continuous RPM, and it lists all of that in the AFM or the POH. With the propeller, you don't have to know as much. You don't have to know like the brand or anything like that, but maybe knowing what it's made out of is helpful. And again, that's in chapter 7. As far as landing gear goes, if you have a retractable gear system, being able to draw out and understand how it works is beneficial to you, and they could ask you that on your check ride. But for me, we have fixed gear, so there's not too much to it other than saying it's fixed and tricycle gear. Or it could be a fixed tail wheel aircraft, whatever that may be. Fuel oil and hydraulic, essentially just knowing how many gallons of fuel you have and how many of those gallons are unusable fuel. Knowing what systems on your plane are hydraulic. Most of the time it's just going to be your brakes, but if you have like a constant speed propeller, or if you do have a landing gear system that's retractable, that will be a hydraulic system. And then oil, just knowing how many quarts of oil you have. You don't have to know what type of oil it is or anything like that. You just got to know where to find that, which is typically chapter 7 of your handbook or manual. And then just knowing what oil does for your aircraft. So it cleans, it cools, it cushions. And yeah, as far as electrical system goes, you just want to know how many amperes your alternator is. At least we have an alternator in my plane, which is a 40 amp alternator. And knowing how many volts your system is and your battery is. So we have a 14-volt system with a 12-volt battery. And the reason that you have more volts in the system than you do in the battery is because the system will be charging the battery as it's running. But we also, if our system fails, we still have some battery charge, which is just like a car. Avionics, just knowing what type of avionics we have. For our plane, there's not too awful much to know about it. And sometimes I'll even lump GPS in there. We have a Garmin 430 in our planes. And again, that's all in chapter 7, letting you know what these systems are. And then we'll skip hotel because we'll make that its own dedicated video. So then environmental, we kind of pair with de-icing and anti-icing, because environmental, that's more just like if you have AC or heating, you would want to know how that works. Most small planes don't have AC, to be quite honest, but heating is very common. And essentially all that that's doing is it's just like a car. So we have our exhaust pipe that comes down, and then we have what's called an exhaust heat shroud around it. So it'll take air, bring it around that exhaust pipe. Those exhaust gases are really hot, and it'll warm that air up around that and then dump that into the cockpit. De-icing and anti-icing, most small planes again do not have that, other than maybe pitot heat is one de-icing equipment, or if you have defrost in your plane, that's another defrost, or that's another de-icing system that will be pretty common in small planes. Water rudders, obviously, we don't have. And then oxygen systems, most small planes also are not going to have that. But let's say you find yourself flying a Cirrus SR-20. For that, you want to know how the oxygen system works. Just be aware of that, which also should be in the chapter 7 of the AFM. Then K2 is indications of and procedures for managing system abnormalities or failures. So it's important for us to understand how all of these things work, because if it were to go wrong, we would be able to diagnose what the issue is and then know where to look to correct it. We would be able to get an idea of, okay, I noticed that this is wrong, so I think it may be this. Now I'm going to run this checklist and see if it fixes, or anything like that. So we familiarize ourselves with these systems and the specific ones to our aircraft for that exact reason. We want to be able to most safely deal with any issues that we may have. And then as far as risk management goes, that's just talking through that detection of system malfunctions or failures. I should be able to look at my ammeter that's telling me how many amps my system is at right now, and if I see that it's in the negative and trending more negative, I can be like, okay, my system's probably failed, my alternator's probably failed. So That means that I'm running off of my battery now, which my battery has a limited life. So that means that I should try and go to land soon, and I should turn off unnecessary electronic equipment. That is just how your thought process should go. That's how those gears should turn. And in that risk management, in the skills of this, they're just going to want to see that you are the most safety minded with everything. You are identifying these things, and then as a reaction, you are not just giving up or not just being like, oh, well, I don't know. You are detecting it, then you're managing it, um, and monitoring what it is that you do. And also just being able to find the correct checklist is another thing. There's not checklists for every single little malfunction or every single little thing like that. So that becomes aeronautical decision making um, and experience. But for the ones that you do have checklists, you could see in a emergency operations part of your AFM or POH, or sometimes an abnormal as well. So that is all for Task G, operation of systems. I'll make a video on the pitot-static vacuum pressure and associated flight instruments another day. But thank you very much for watching, and I'll see you in the next one.